Hello from Moscow, everybody. Apologies for not being with you. Something urgent came up. But it's great. It's my second year speaking to you. Since we don't have that much time, in August 2015, I'm lounging at the island of Hydra in Greece, having a good time, and then I have this telephone call, and it's coming from from a correspondent from one of the Russian newspapers, and of course I don't bother. And then another one comes in from another newspaper, and then I look. Something is going on, right? Something is going on. The sad fact was that by the end of the 2015, I was actually getting used to these calls, because in 2015 we experienced the most incredible series of exchange systems failures, outages, attributable to different causes, different situations, and really towards September, October, it got to the point where we really didn't know what to do, and it could be we thought it could be the giant fluctuation or the sun activity, right? So a little bit about the causes and the background of this whole situation. For those of you who remember the conversation last year, Moscow has unusually sophisticated or complicated setup for risk management. Unlike many, I guess the majority of the exchanges that control the risk after the trade is done. It could be the end of day or with some delay. Russian exchanges, MOEX, controls risk before the order is even placed in a book. So that slide is pretty much lifted from the last year's presentation or before that. And our picture is on the right. This is what we call a real-time order pre-clearing. And at that time, I actually said that it looks great, right? It allows you to do things that generally, it allows you to protect yourself from market meltdowns, from stupid trades, from people trading without collateral, all that sort of stuff. But it introduced a liability, right? And the liability is this. Whenever a clearing system, whenever your risk system fails, you have to stop trading. You cannot trade anymore because every order has to pass through the risk system before it even gets into your matching system. And if your risk system is not working, matching system could be perfectly healthy, but it's not really doing anything because it doesn't have anything to trade, right? So that actually proven to be a prevalent mode of failure for us in 2015. So this is the inglorious 2015, right? We had major hardware faults or hardware-related faults because at that time we didn't even know that it was hardware as such. The fault that I started my conversation from in August was actually affected all three markets, all three trading systems, all three major trading systems that we run, and it was attributed to the network inundated with some sort of traffic that essentially we got the network storm, right? A traffic storm that flooded us. We couldn't really do anything, right? We have two other cases where, and I'm sure those of you who operate the exchange plant, the hardware plant, build some sort of a fault resilience in your systems. Some way where there's a backup component and it knows how to take over the function from the primary component and all that sort of stuff. Funky enough, a good friend of mine who still now works in the United States, always worked in the United States, and ran the infrastructure for a major U.S. bank, was always an opinion that this sort of structure is actually more trouble than good, and they become the source of the fault as often as they save you from one. In fact, in our cases, the other two hardware faults were actually also related to, at least we believe, to network failures where the backup and primary components lost sight of each other got out of sync, went mad, and that's what killed us. If we didn't have backup, probably would have been running, right? And then the next cluster is 3 failures, and mind you, it is a real market outage. It's something you have to, something gets into the newspapers, gets in the newsprints, says, "Oh, Moscow Exchange has another outage." Oh my God! And like I'm the CIO of the Moscow Exchange, and I'm of course presiding over all this. So 3 other ones were the classic failures that I just described. When you have a fault in a risk module which prevents you from doing risk checks on the incoming trades, incoming orders, and you have to shut down matching engines simply because they don't get the orders to trade, right? And the last lonely thing is it's actually the failure in the matching engine itself, which doesn't really happen much to us. In fact, it really never happens. And I think that's the kind of failure that other places usually experience, but we had just one of them. But cumulatively, if you count the event of the August 12th as 3, I cannot even add them up, right? It's horrible, right? So we had lots of. So that's our sinkhole, right? Sinkhole, for those who don't know, it's the interesting geological thing. Formation usually, I experienced it in Mexico, for example, when you just fall through the ground and there is like nothing underneath, although it seems like a firm ground. So we're in a sinkhole. What do, right? So much is said about the good software development practices, right? And old-timers like myself, are used to things like code reviews, and the whole protocol for code reviews, and the reviews of the requirements, and where essentially the whole chain of instructions and chain of actions that lead to a software product goes through the continuous review and examination process. These practices kind of like got not subverted, but really not paying that much. Really not using. They're not being used that much these days, mainly because the productivity of the developer became the most. I think the predominant factor that defines what we do and what we don't do. So we had to return to more or less the old style practices, the kind of development practice that we we used in Bell Labs in the 90s, right? So we greatly expanded the test coverage, right? We started using the automated tools for testing. All those things people say they do, or in reality don't, or don't pay that much attention. We started actually doing them religiously. So we increased the coverage for automatic testing. We started doing the destructive testing. We stopped just checking for the functionality. We started seeing, can you actually break this, right? In my olden days, we had a test group which was specifically tasked with breaking. Don't look at what the software does. Try to kill it, right? So this is what we started doing, and doing a lot of it. We acquired a lot of tools. Some of these really fashionable tools. I don't know how many of you are using Coverity as a tool. It helped us tremendously as a static code analyzer. We started using dynamic code testers. We went into the certain mode of development where essentially what we started doing, we started pushing testing towards the very beginning of the development cycle. So things like continuous integration. As soon as the change is made, we build a product, it immediately gets into some sort of a test. Developers have become far more active in testing activity. We started doing code reviews, like the real code reviews, and actually in 2 modalities, right? Some of them we actually would sit down and read the code. Also, all of the changes that are being made now are sent to another developer just for the quick perusal, right? So you write a code, at the time when you want to check it in, it pops up on somebody else's screen, and that somebody else usually read it. The value of this is not necessarily that that other person is going to find anything, is that you know that your code, it will be looked at by another person. And it kind of like changes attitudes, it focuses you, it makes you far more diligent in your task, right? So altogether, that actually increased the duration of our release cycle, and but it led to results. So if you look at the slide, so these are like in this red, these are things that we added to our normal processes, right? We started testing. We started doing static code reviews, dynamic reviews, destructive testing, something we call simulation testing, where we put a system that's near production into essentially production harness, where it receives the full traffic coming from the live feeds from the actual Exchange ecosystem. So essentially sitting in a quasi production environment for a couple of weeks until it actually gets into production. All right. So that's the stuff that we did in software development cycle. There's a list of tools there that we deployed, right? That doesn't mean that every development group uses all of them, right? We have essentially three development groups, and they use different tools for different reasons. But that's the full list of stuff that we actually deployed, brought in. It took a little persuasion to actually convince the company to buy all this, but it really helped us a lot. So I'm going to go to the next slide, right? So this is what our release cycle looks now, and the deal is this, right? So I go to my business partners and say, oh, listen, I'm going to be testing things now. I'm going to add 8 weeks or 12 weeks of testing into the end of the cycle. So normally Moscow would release in each market, have 3 releases a year. So altogether that's 9 releases, plus we do the major industry-wide testing for our systems. So that practice, essentially what we decided to do, we decreased the release frequency to 2 releases a year. And I think it actually worked out really well for us. It worked well for us, and it worked well for our partners, for the brokers, for banks, because in reality they really could not keep up with us, and that gave us extra time to really work on the quality assurance. The cycle, I'm not gonna go through every step. You can just look at it. If somebody needs this presentation, you can have it. If you want to talk to me about this more, or somebody, there are people from MOEX in the room. They'll tell you more how it works. Again, effects are very visible. We created a formal metric for release readiness. So we track every bug as we discover it, as we discover the defects or changes. It's only when that curve dips below the level set on the executive level of the company, only then we deem that release is suitable for production. Okay, I'm going to go to the next slide. Am I doing on time? I'm good. Now, we didn't forget about those 3 major outages that we had related to hardware. And as it turned out, that I'm shifting gears now, right? So I'm going from software development into hardware and into our hardware plant, because as you remember, our Sinkhole is a 2-component Sinkhole. It's a software and a hardware Sinkhole. Our network architecture, and I don't know how many of you are still using it, but it's pretty widespread, right? Especially a spanning tree architecture for the network, built in the data centers during the times where a majority of the traffic was in and out of the data center, right? I'm not going to go into the details of the algorithm, but part of it requires a propagation, distribution of messages in the network that allow the network to reconfigure itself so it actually looks like a tree and not like a graph, or God forbid, a cyclical graph. It turned out that in our case, some of these messages, for reasons I'm not going to go into, sort of like started circulating in the system, accumulating, because they all are of a kind that simply accumulate. They don't die. Unlike the your normal TCP IP traffic that has the time to live parameter set, those messages are TTL0, so-called. They never die. So over time, they just accumulate, and they clog your network. And that's the clog killed us on August 12th. So what we transitioned to, we completely changed our network architecture. We went from this spanning tree architecture to spine and leaf architecture, the flat network structure, which is organized and managed on a totally different principles. Again, I'm not going to go into the details here. We'll be glad to share those with you. And on top of that, we split our net into 3 segments at really very high cost. So essentially, we trebled the amount of the network equipment that we run. But now we have a production segment that's more or less physically segregated from everything else, right? We have a test segment that's more or less like separated as well. We have office and development that kind of like live together, and that's where everything else is happening, right? We do some interesting networking experimentation since we're using ultra high speed bus as a foundation of our systems, and the protocols, the network utilization, I guess modalities that we have are sometimes not necessarily dangerous, but you don't know what the consequences are going to be. So now we can test and develop in more or less in with this feeling of relatively safety, knowing that none of this traffic is going to leak into our production segments. Production segment is sacred and it's physically segregated. But again, it costs a lot of money. The company was willing to go with this because after the 2015, I think we're willing to do more or less anything. Okay. Going to the next slide. Look, this is what people do when they get 12 outages a year, right? We created a technical policy. We actually created it much earlier than that, which essentially says that nothing that will run in production in our mission critical systems, and that's about 400 servers, I would say, can be older than 3 years, right? Essentially, it means that for those, we have to replace our park every 3 years. And we were like going about changing things at the pace of about 30% of equipment every year until 2015, which was the second year in the operation, where we decided that, nope, we're replacing all of it, right? And that is the shift that was made from 2015 into 2016 and 17, right? So what's red on the left side is actually equipment that was older than 5 years, right? We bought all the new equipment, and again, we're not silly. We don't put new equipment into production. It sits in a quarantine, essentially running full load for 3 months to burn out all the defects that could have been in manufacturing or the ROM. But when it's done, it goes into production. So now our park is essentially under 3 years old. I don't know if other people are that aggressive, and I'm not even sure this level of aggressiveness is warranted. But again, if you're in a sinkhole, this is what you do, right? It requires resolve. It requires money. The one thing I want to point your attention to is that something's called criticality class. So that is something that we keep track of for every system, every hardware component. We assign these criticality classes 1A, 2A, 3A. And there are rules. It actually helps when you go to your purchasing and cost control and budgeting people, and they tell you like, look, this is too much money. You say, look, this is the policy. This is what we do. We can either violate the policy or we can live with the policy and we abide by the policy. If we're violating the policy, why are we having the policy? So far, I managed to get away with this. All right. Flipping forward. This is not a result. This is a new data center that we moved into, right? This is not a result of the outages. We were planning to do this for a long time, but as it goes, it helped because the target availability that we have is 99.98% availability. That gives us about probably 2 hours per major market, right? We have 3 markets: FX, derivatives, and everything else, more or less, equities, fixed income, all trading together, money market. So it gives about hour and a half, 2 hours per market. 99.98 is our goal. We moved into what's called the Tier 3 facility. At that time, that was the only Tier 3 facility in Moscow, and now there's quite a few of them, which has this rated reliability for its core engineering system at 99.98, so it matches ours. So on a purely formal basis, we couldn't really use a Tier 2 or Tier 1 data center because the reliability of the engineering infrastructure is less than what our supervisory board, what our board of directors set for us as a goal. Okay. Going forward. So that's the icing on the cake. So as we refactored our system, as we went through our code, as we examined the lines of it, as we increased the test coverage to some automated test coverage to about 65 to 70%, we actually fixed a lot of interesting things, discovered the performance bottlenecks and all that sort of stuff, and achieved significant improvements in our performance. So it's the quality. I think the message here is that quality and work on quality assurance actually pays. It pays. You get this collateral benefit of overall improvement in your system. It just runs smoother. It runs better. If you look at the picture in the lower right corner, this is the jitter on 2 network protocols that we're using, right? And you see that the red, it's a nice narrow peak, and what's on the right, the blue thing, I cannot even look at it. It's horrible. Looks like a hairy monster. We don't want this. All right, so that's a slide. That's climbing out of the sinkhole on a little graph. We basically we're maintaining 99.98% availability through 2014. That's a huge dip to 99.95. It cost us a lot in many ways. And by 2016, we returned to 99.98, and we're still there. The practices that we introduced, it stayed with us. They became part of the culture, part of the not the religion, I guess, but it is culture, right? It's unthinkable that we do things not abiding to those rules. Whenever the business asks us to do things faster or cut those corners, they just don't do it anymore. They know that this is not how we work anymore. And I think just judging by the result, I don't think anybody's regretting the outcome. So that's the end. This empty slide. Thank you for your time, attention. Unfortunately, I cannot hear any of you. There's no feedback here. If you have questions, and there is a way to, I guess, send the questions my way. I'll answer. But if you need to, if you want to speak to somebody more, our head of development in derivatives is in the auditorium. Vladimir, maybe you can wave your hand, and if you want to speak to him, he'll either give you my contacts or I'll tell you more about what's been happening. All right. Thank you.